Welcome to this video. In the previous class, we talked about what is a reciprocal function, and the graph that you see right now, this shape is called a hyperbola. We should be pretty familiar with it because we talked about it in class. So the reciprocal functions, they would have the shape of the graph would look like this, a hyperbola. Okay. As we know, we're going to have a horizontal asymptote, which is in this case, as my equation is 1 over x, the most simpler form of my reciprocal function, my horizontal asymptote is going to be the x-axis. My vertical asymptote is going to be my y-axis. Again, this horizontal asymptote and vertical asymptote, they are on the x and y axis respectively because my equation is 1 over x. Okay, so if today I want to know what is the graph of say 5 over x, let's say 5 over x. Now how is that gonna make the graph different? So let me just copy this. Let's say this is my y, my original y1 is 1 over x. And now I have 5 over x. Okay. So you can see that the red line, the red graph, that's my original 1 over x. And when I change the 1 on top, when I change that to 5, my graph looks like it's now, so in before I had 1, there was 1 point at 1, 1. Right? Now if my x is 1, my y is now at 5. So let me just put those points down. I'm going to use 2 points, 1 point from each graph to help us to see the transformation that we have. So originally, when my x is 1, my y is 1. And now, with this 5 over x, when my x is 1, my y is 5. So what happened? My x did not change, right? My x did not change. But my y has changed. My y has went up. My y was 1, now it's 5, so my 1 multiplied by the 5 became that. Now, where did that multiplied by 5 come from? That is this 5 over here, right? Because I can rewrite this as 5 times 1 over x. Right? So this, I can rewrite this as 5 times the original equation. Right? So in other words, my vertical stretch. Make sense? That's my vertical stretch. Okay. However, you see that we have not made any changes to my x, to my horizontal and vertical asymptotes, because I'm not. In order for us to move the location of my horizontal and vertical asymptotes, I must be carrying out some kind of vertical translation or horizontal translation. But right now, this 5, it's just a vertical stretch, so it's not going to affect our asymptotes. Okay, so now we talked about this in class already, and if you need help, please come talk to me about it. Now, in this video, I'm going to focus on how to change our equations. Let's say today I want to see the equation of this. All right, I want to see the equation of, say, 1 over x plus 3. Okay, 1 over x plus 3. And I'm going to change it. I'm going to use the function representation to help me out here. So let's say my original f of x is equal to 1 over x. Now, I have g of x is equal to 1 over x plus 3. I can write this as, how can I write this in terms of f? This would be f of 1. So what do I substitute the x with? If I want to represent the function g, which is 1 over x plus 3, if I want to use f of x to represent the same equation, and I'm going to change the x. So I have to replace this x with something, just the x, yeah, just the x. I'm going to replace the x with something, so I will get 1 over x plus 3. That would be 1 f of x plus 3. Does that make sense? So in other words, if I say my g of x is equal to f of x plus 3, that's the same thing as saying g of x is equal to so what's f of x? F of x is equal to 1 over x. So I'm going to put the 1 over there, right? 1 over, well, this x is not there anymore. This x is going to be x plus 3. Okay? So even until now, we are just reviewing on the transformations and the function part that we learned in chapter 1. Right? So when I show the graph, what do you think? What do you think the graph is going to look like? I'm adding a 3 to the x, right? I'm adding a 3 to the x, and you can see the equation over here. I'm adding a 3 to the x. So if I know my f of x looks like that, when I activate this g of x equals 1 over x plus 3, which is adding 3 to the x, this whole graph should shift to the left, right? It should shift to the right, to the left. So this, I had a point at 1, 1. Let's give ourselves a few more points. I'll have another point at -1, -1, right? And I have this vertical asymptote, horizontal asymptote. So if I'm moving the whole graph to the left, I will have this points 1, 1. It will be at 1 end. So 1, if I move to the left by 3 units, I'll be at -2. If I move this point to the left 3 units, I'll be at -1. Oh, I'm sorry. I think I made a mistake here. Sorry about that. Since I'm moving to the left, my y is gonna stay the same, but my x will change. So please be careful. Don't make the mistake that I just made. Yeah. So I'm here. If I move to the left 3 units, I'll be at -2. So and the next point, -1 and -1. Now, if I move this point to the left by 3 units, I will be at -4. And let's see if we're right. But if you think about this, shouldn't my horizontal and vertical asymptotes, one of them is going to move? Is my horizontal asymptote going to move? No, my horizontal asymptote stays the same. Right? Horizontal asymptote is going to stay the same. So I'm going to have y equals to 0. That stays the same. Okay? Let's change that to dotted line. So what about my vertical asymptote? My vertical asymptote, since the whole graph is moved to the left, so move to the left by 3, my vertical asymptote is also going to move to the left by 3. So instead of x equals 0, it is now going to be at x equals -3. All right, so we have carried out the transformation with the respective points and the vertical and horizontal asymptotes. Now let's see if the graph is correct. There you go. That's it. So this is this graph right here. Let me change the color. I'll change that to blue. The blue graph, this hyperbola, is the graph of 1 over x plus 3. And as you can see here, I've just moved the point to the left 3 units, moved this point to the left 3 units, moved the vertical asymptote to the left by 3 units. The horizontal asymptote stays the same. Okay, so that's it. We are just simply applying our knowledge on transformation. So you see that I can get a rational function. This is called a rational function, right? This is called a rational function from a reciprocal function by carrying out some transformation. Now, let me ask you, I would like you to answer this. What would what would the graph of this look like? Say h of x is equal to 2 over x, let me hide this. Let's say 2 over x minus 3. I would like you to pause the video now and think about where is your vertical asymptote going to be? Where are your so compared to the original reciprocal function, the 1 over x, right? So you can compare to this 1, 1 and this negative 1, negative 1. Compared to those points, where would those points now be? All right, think about this. So this minus 3 is very similar to what we did just now. That is, what is that going to be? What about the 2? The 2 is, we also talk about this in the very beginning of this video. So think about that and pause the video, and then when you have the answer, you can start playing again, okay? Okay, welcome back. I hope you have tried to find the respective coordinates of my h of x for these 2 points, and also figure out the new locations of my asymptotes, if they have changed. So let me rewrite my h of x. My h of x is equal to, so this 2, I can bring that 2 to the front. 2 times 1 over x minus 3, right? Which means my h of x is equal to 2 times, now this 1 over x minus 3, if I write this in terms of f, which is my f of x is equal to 1 over x, okay? So how can I write this 1 over x minus 3 in terms of if I want to use the f of x? So here I have f of what? So f of what will give us 1 over x minus 3. I hope your answer is x minus 3. Right? So if you refer back to my f of x, this is my f of x. And if I change this to 2, then that becomes 1 over 2. If I change this to 12, that becomes 1 over 12. So if I change this to f of x minus 3, then that becomes 1 over x minus 3. Okay? Hope that makes sense to you guys, because we did this in chapter 1. Yeah? Okay, so now let's go back. Now that I have converted my h of x into a vertical stretch and a horizontal translation, I can predict my points. So my points would be 1, 1. I need to move to the right by 3 units, and then multiply my y coordinate by 2. So that would be 4, 2. And then for my other point, I'm going to carry out the vertical transformation first. So I'm going to multiply the y, which is negative 1. Multiply that by 2, I'll get to negative 2. And then I'm going to move my x to the right by 3. So that gives me 2, negative 2. So in this case, I don't really have to worry about the order. I can carry out the vertical transformation first. In other words, multiplying all the y coordinates by the 2, and then move the point to the right by 3. Or I can do it the other way around. I have only one vertical transformation, only one horizontal transformation. We don't have to worry about the order. But if we have 2 of the same type, then we need to be careful with the order. Okay? So now if I show my graph, which is over here, you see that my hyperbolas pass through the 2 points, which is good. And the last bit would be my asymptotes. If I move into graph to the right by 3, my asymptote would be at x. My vertical asymptote would be at x equals to 3. And my horizontal asymptote will only be affected when I'm going up or down. In this case, we're not. So my horizontal asymptote stays the same. All right, I'll see you guys in the next video. Bye bye.